All right. Objective 4, form the sum, difference, product, and quotient of two functions. So basically, can you add, subtract, multiply, and divide things together? Okay. So first rule, sum. If it says f plus g, that means you're taking the f function and adding it to the g function. Okay. Literally. If it says f minus g, that means you're taking the f function and you're subtracting the g function from it. Okay. Essentially, with both of these, you are combining like terms. Okay. So when you are adding or subtracting functions, you are combining like terms. Got it? Everyone good? Okay. Next, our next two rules are product. If you're multiplying, you're literally going to follow your multiplication rules, and you got to remember your exponent rules. So remembering your exponent rules, if I have x times x squared, what does that equal? Anyone? X cubed. Thank you, Piper. Okay. If I have x, 2x, parenthesis, to the second power, what does that equal? 4x squared. You have to distribute the power to both. So remembering our exponent rules is important when you're finding the product, okay? If I, on to quotient, okay? On to quotient, if I have f divided by g, and it's f of x divided by g of x, you still got to remember some of your quotient rules, such as if I have x to the third divided by x, what does that mean I'm doing with the powers? Subtracting. So it's 3 minus 1, which equals what? 2. So it becomes x squared, right? Remember those rules? Okay, they come into effect. If you cannot simplify, then you're done, okay? If you can't simplify, you just work it until you're done or you can't simplify anymore. All right, so we're going to start here with f plus g. Again, you may need to do some paper, who knows? Sorry. So if we have f plus g, we're taking f of x and adding it to g of x. So that gives us 2x squared plus 3 plus 4x cubed plus 1. Remember, when you're adding and subtracting, that means you're combining like terms. What are my like terms? 3 and 1. I have a positive 3 and a positive 1. So my final answer would be 4x cubed plus 2x squared plus 4. How do you feel about adding? Yeah? Yeah. Okay. Now we're going to subtract. So we have f minus g. Now, when you're subtracting, you have to utilize parentheses. So we have 2x squared plus 3 minus parentheses 4x cubed plus 1. Okay. The reason why you have to use parentheses is because you have to multiply by a negative 1. Because remember, subtraction is just adding a negative. Do y'all remember that? So this is actually 2x squared plus 3 minus 4x cubed minus 1. Okay, so now when I look at this, my answer is negative 4x cubed plus 2x squared, but plus 2. Questions, comments, or concerns about adding and subtracting? Nope. All right. So we're going to do multiplication. Now with multiplication, we learned several methods. You either can do the traditional multiple distribution or you can use a box method. Does it matter which one you use? No. So if you're doing traditional, you have your 2x squared plus 3 times times 4x cubed plus 1. Okay, so if I have this, and I'm going to have to make sure I distribute everything accordingly. So 2x squared times 4x cubed is going to give me, ax to the 5th. Okay, I'm going to distribute. So I have 2x squared times 1, and that gives me 2x squared. I have 3 times 4x cubed. That's a square. It got weird. What's 3 times 4x cubed? 12x cubed. And I have 3 times 1, which is 3. Okay. Are there any like terms that need to be combined? No. In theory, you're done. If you want to be mathematically correct, then you would put them in order by the powers. So if I wanted to be mathematically correct, I would write it as 8x to the 5th plus 12x cubed plus 2x squared plus 3. Is it necessary? No. But it makes it make more sense in my brain. Okay, so we've now done addition, subtraction, multiplication. What's left? Division. All right, so dividing. So I have 2x squared plus 3 divided by 4x cubed plus 1. If there's no common factors, you are done. And that's because there are no common factors. I can't factor or I can't reduce and eliminate. They have nothing in common. The binomial in the numerator is different than the binomial in the denominator completely. Yes. All right.
For today? Or do we have a?
All right.